Okay guys, going to give a look there. So at 2020 question 8 for engineering. So the first one there is just on crank and slider mechanism and the advantages of power tools. Okay, so describe with the aid of a diagram how a motorized crank and slider activates the cutting blade. So like basically what you need here is a sketch. So I'm going to sketch a crank, which is basically a spinning disc, and I suppose the tricky thing here is just to put some kind of a sketch over here to show a slider. So the smart thing to do here is I'm going to just draw a box sort of in the middle of a guide is what I'm going to do, and I'll just okay, so something like this now, and if you leave the connection here in the middle of that slideway, and what I'm going to do here there then is I'm going to put a circle here, a connection there, and basically I'd be in the habit of doing these freehand, but maybe if I just draw a light line there, and I'm going to put some colors on this now just to make it look better. So if I'm going to put this so that there's just a link, so that's a linkage, and I'll just put a color on our crank here. So as our crank spins around, so this would be connected onto a motor, just a regular motor. So that crank spins around in a circle, and that is going to be pushing this over and back. So finally there now, I'll just use a different color on this slider, which I'll put in blue. And I'll just, this kind of a housing here for the slider, I'll just color that in red as well to and as so it asks us there to describe with the aid of a diagram. So the crank rotates and the slider reciprocates. Over and back. Now the blade is connected to the slider. Okay, so the crank rotates and the link pushes and pulls the slider. Okay, so this whole thing is basically it converts, okay, so it's a mechanism, so it converts rotation to linear reciprocating. Motion. Okay, so that's the first part of it done. Now the second part of it there, it just said there to identify one advantage and one disadvantage of cordless power tools. Okay, so that's A part 2. That was A part 1. So an advantage. Okay, so an advantage of cordless power tools is, okay, you don't have to run, there's no leads or extension leads or cables, etc. So if you're up on it's handy up on roofs, etc. And a huge one here is there's no need for electricity. So if you're out on a building site, what's called a greenfield site, where there's no electricity connected up, if you're building a timber frame house, you know, well, obviously you need your tools charged, but you don't need electricity for them. Okay, so they're the advantages and the disadvantages. Okay, so one is they can be easily stolen. Batteries die. And need charging. Now they're not as strong, powerful as mains / 220 volt tools. So if you have something plugged into the wall sockets, an electric cable there, they're generally, even though they are improving all the time, and so they ask for one, but battery tools are improving, and the gap between them and the mains electric ones is much smaller now. Okay, so that is the first one done. Now part B there, then I'll just fit one on here, I hope. So it's helical versus spur gears. Now I'm going to try and sketch these basically, even though it's not so easy, I guess, but spur gears, it's kind of a thing now that it's easier to sketch. Just sketch this light. So spur gears, the gears, I'll just sketch in 1 or 2 teeth here now on this. A few teeth will do. Okay. So spur gears, are straight across. Okay, so they're cheap. Okay, so they're cheap and fast to make, and they work well at low speeds, but they vibrate at high speeds. Okay, so spur gears are very common, like they're the ones that you would find the most. Now, so there's my gear there. So they're the ones that are just straight across, what you'd call a normal gear really. Now I'll just attempt there then. Just draw an ellipse, light, just extrude it. So there's just a little bit of a cylinder. Put a hole in the center of that. Now a helical gear is running more along like this. Okay, so they're running across. So a helical gear runs at an angle across the cylinder of the gear. So helical gears. So obviously they're more expensive to make. They last longer. They run quieter, especially at high speeds. Okay, so and yeah, that's loads anyway, that'll do for that. Now question 2 here then is advantages, 2 advantages. Okay, so 2 advantages of roller bearings. Okay, so they are better able to take shock. Oh, that's S-H-O-C-K, as shock or impact loads. Than ball bearings. And they work better at low speeds. Okay, so I'll just stick in there in brackets. High speed or high revs per minute suits ball bearings. Okay, so next there then, number 3. Now you only had to pick 3, there is 5, so I'll look at all 5. So the third one there is describe how the camshaft opens the valves in a 4-stroke engine. Now basically there, what you want to do, I'm just trying to keep this small now, is I'm going to draw cam. Again, there I'll just stick in a bit of colour there. Onto that. And somewhere down here you would have some kind of a valve. I'll just stick in something simple here now. Just put a bit of a spring on that. And as the camshaft rotates, the valve will be pushed up and down. So again, so the camshaft rotates and the valve reciprocates up and down. Okay, so basically the cam pushes it down and the spring closes it. Okay, so that will do for that. Just click on there to the next question is two lubricants. Okay, so two lubricants which reduce wear in gear mechanisms. So obviously, just to identify it, so you would have oil and grease. Okay, so I think that'll do there. That engine oil basically is a lubricant, and you'd put grease on bearings and stuff like that. And then finally there, question 5. Explain how a double acting pneumatic cylinder. Okay, so a double acting cylinder. Okay. So just get a pencil for drawing this. So basically what you want to draw here is some kind of a box, really. So I'll just sketch this pretty light here for a second. Just a box. But it's now in reality it would be a cylinder, but that doesn't matter. So there's a box. I'm going to draw inside this a piston. Now that's basically just a circular disc then, and I'm going to draw a ram that goes out through the box. Okay, so there's our ram and piston. Okay, here. Now what you would have there then is a hose pipe going in here, so I'll just put a connection onto this here, and an air hose or an oil hose, whether it's air powered or oil powered. You're going to have, and I'll just put the other one down here. Okay, so let's say it's pneumatic, so it's air. It doesn't matter, but either way, when you pump air in here, so you've got air or oil ports. So one here and one there, and let's say we pump air in here. Okay, so when we pump air in here, this one allows the air to go out, and the air forces the piston to the left. But basically a double acting cylinder has power in both directions. So that's the key thing, a double acting cylinder, because sometimes they just have a spring to return it, so it's powerful in one direction and a spring then would push it back. But a double acting has power in both directions, equal power. So the oil or air pushes the piston, moving the ram. In either direction. Okay, so that is that one, and the last part there then C. I need to get some more paper now, I guess. Okay, so there's probably a few correct answers to this, but what I would say there, just to keep it nice and simple, is I would just draw two circles like that, and just draw a little section up here of sprocket gears, and I would use a different color there then if possible, just to highlight it, and we'll just put in here and you could go to town on it and put in all of the links there of a chain, but like that will do. That gets the point across. So there's our shafts. So I would say this is C, and just say I would use chain and sprocket mechanism. Okay, so it is strong and does not slip. So that would be the first one. Just scroll down here. So describe with the aid of a diagram a suitable drive mechanism for the surveillance vehicle. Okay, and the second one there then is describe with the aid of a diagram a suitable mechanism that will rotate the camera 360 degrees. Okay, so that's C part 2. Now, again there, what I want to do here is just use some color. Now, the easiest way there is, let's say you have a shaft. I'll heavy this in afterwards, but you have a shaft and here's your camera mounted on top. Okay, so I'm gonna just leave this in 2D. So here's the shaft, here's the camera, so obviously, like, you know, you could put a lens or something there to indicate that there's a lens or something, but it doesn't really matter because we're more interested in what's gonna spin the shaft around. Now, what you could do here then is you could mount a bevel gear on this. Now I know a few people probably have been looking at using this on their project. Okay, so what I want to just put on this now is a couple of teeth. And I'll just show the rest. Show that shaft coming down through there. And what I want to put now is another shaft. So I'm going to use the side of this here, and I want to show another shaft and another bevel gear coming onto that. Now I'm going to put some colors on this in a second. So I'll just make this one green maybe. And I'll just make this one blue. And that'll do, and I might just, so here is my shaft. And here is the other shaft. And obviously there, when this shaft rotates in this direction, it's going to turn that shaft, well, it can turn either way really. So just say a mechanism with two bevel gears and shafts at 90 degrees would work. Okay, so a motor turns the blue shaft and it will rotate the green one and shaft, turning the motor, turning the camera. Okay, so I might just brighten it up there by colouring in my camera up here. So have a couple of colouring pencils in with you in the exam there, and that would explain that now fine. I hope that came out on camera. Now the last part of that there, if you were stuck, now obviously you only want to do one of these, is that's solar panels. They're photovoltaic panels, are often used to power flashing beacons at pedestrian and train crossings. So explain one energy conversion that takes place in the photovoltaic panels. Now the energy conversion there is basically this heat and light from the sun is turned into electricity. So that would be the conversion from one form of energy to the other. And one advantage and disadvantage of photovoltaic panels. So obviously the advantage is that, you know, they're solar powered and you know, they will work away every day, the battery doesn't die or whatever. A disadvantage of the photovoltaic panels, well, if you're in a country like Greenland or Iceland, or, you know, up in Scandinavia in the north of Russia or whatever, where you know, you can get 4 or 5 months of no sun, your solar panels aren't a whole pile of use to you in countries like that. But I'm not going to write that down there, but you could always throw down something there to get you out of trouble.